Hello everyone. This lesson we will learn Y-shape motor control. The Y-shape control is suitable for the medium and high-power three-phase motors during normal operation. When the motor is started by Y-shape, the current of the power supply line can be reduced to 1/3 of that by shape connection, effectively avoid the impact of excessive current on the power supply circuit. Next we use PLC to control the traditional relay contactor of the motor. First of all, we will learn the TON, turn on delay instruction. Timer is seen on figure. TON at the top indicates that the delay timer is turned on, and IN indicates that the enable input. Q stands for enable output, PT represents the timer's preset time, ET represents the current variable time, and %dB2 represents the timer's background block. The working principle of timer is shown in figure. Timer begins when the enabling input IN circuit of the timer changes from 0 to 1. When time is greater than or equal to the present time, PT is specified setting value, the timer stops timing and remains as the preset value, that is, the time-consuming value ET remains the same, and the timer remains active as long as the input IN is 1. In the design of PLC program, the first thing is to be input-output address distribution. In this task, when pressing the start button SB2, AC contactors KM1, KM3 and timer K to get power, the motor first do Y-shape start. After 5 seconds, when the motor speed is close to the rated speed, KT disconnects KM3, turns on KM2, and the motor makes shape continuous operation. When press stop button SB2 or thermal relay KH action, the motor stops running. This task involves the switch of contactor KMY to KM, which can be controlled by the soft relay timer T in PLC, so that no time relay hardware is needed. In addition, contactor KMY and contactor KM cannot be electrified at the same time, otherwise the power will be short-circuited, so we must consider adding software and hardware interlock control at the same time. According to the above analysis, I/O distribution table of PLC can be obtained as shown in the table. Input device is start button SB2, function is start, input relay is I0.0. Input device is stop button SB1, function is stop, input relay is I0.1. Output devices are contactors KM1, KM3, KM2. The role is to control motor power, Y-shape connection and shape connection. The output relays are Q0.1, Q0.2, Q0.3. The picture is three-phase motor Y-shape start of PLC wiring. See the video for details of the installation process. Three-phase asynchronous motor Y-buck start PLC control peripheral wiring. Let's take a look at a good three-phase asynchronous motor, star delta buck starting PLC control peripheral wiring. Three-phase asynchronous motor star delta buck start PLC peripheral wiring. We need to complete the PLC power interface, input terminal circuit, output circuit wiring respectively. PLC power wiring. 1. PLC needs to be connected to a 24-volt DC power supply. PLC L+ connected to the positive terminal of the 24-volt power supply is also connected to the power module plus V. Connect M to the negative pole of the 24-volt power supply, that is, to the V of the power module. Connect L and N of the power module to 220V power supply. PLC input circuit wiring. Connect 1M of the input circuit to M. Combined with I/O assignment. We need to connect the start button SB2, stop button SB1. I0.0 and I0.1 of the PLC and L+ respectively to form the input circuit. PLC output circuit wiring. 1. For L+ of the PLC is connected to the positive terminal of the 24-volt power supply. For M is connected to the negative terminal of the 24-volt power supply. 2. Combined I/O assignment. We need to connect 3 output indicators HL1, HL3 to PLC Q0.1 to Q0.3 respectively. The other end is connected to 4M to form an output circuit. In the program, the start button is connected in series with the stop button for output, and the start button needs to be connected in parallel with the normal open contacts of the output relay to form a self-locking. Start button is the normal open button used by the hardware. The normal open contact used in the program is disconnected in line with the requirements. Stop button is the normal close button used in the hardware. The normal open contact is used in the program, switching on branch to meet the requirements. Let's learn about program input. Find the main program, main, of the PLC in the project tree. Double-click to open it. Click on the normally open contact and enter I0.0. Click on normally closed contact and enter I0.1. Click on the output coil, assignment, and enter Q0.1. Click on the bus on the left to add a new line and select the right arrow. Open branch. Click on the normally open contact and enter Q0.1. Click on the up arrow. Close branch to connect the lines together. Click here on the horizontal line and click on the right arrow. Open branch to add a branch. Select the normally closed contact and enter M0.0. Click on the output coil, assignment, and enter Q0.2. Click here. Select the open branch. Find TON on the right-hand side and use the default data block. Change the value of PT to 5S, change ET to MD10 and select the output coil, assignment, M0.0. Select normally open contact and enter M0.0. Select normally closed contact and enter I0.1. Click on the output coil, assignment, and enter Q0.3. Change the Q0.1 variable name to motor KM1, controller KM1. Change the Q0.2 variable name to motor KM3, controller KM3. Change the Q0.3 variable name to motor KM2, factor KM2. After writing the program, click on the Compile button. After compiling, if there is an error in the program, a specific error message will appear. Click on the Start Simulation button to load the program. Start searching, select the searched PLCs and finish. Turn on Program Monitoring, monitoring on. Adjust the PLC to run mode, you can see that the green line indicates on and the blue line indicates off. Afterwards, start verifying that the program is correct. Click the Start button, Q0.1 turns on, Q0.2 turns on. The delay command, TON, is activated, and after 5 seconds, Q0.2 is disconnected and Q0.3 is activated. Click to stop I0.1 disconnected, Q0.1 disconnected. Connect the circuit correctly as shown in the figure, press the Start button after downloading the program, observe whether the motor can run correctly, wait for 5 seconds and observe whether the motor speed changes. Press the Stop button and observe that the motor is able to stop running. Please finish your homework. The above content is how to use PLC for Y-shape motor control, including I/O address distribution, PLC wiring, program design, program input, program simulation verification of learning. Thank you.